So we are going to discuss the intuition-based questions from Codechef and Codeforces. A bit big. Fine. Okay. So the intuition-based questions from Codechef and Codeforces. Then we are going to talk of GCD, that is the greatest common divisor. Then combinatorics. Then primality testing. Common doubt discussion would be there. Also, you need to understand that it's just a tool and it's not something too complicated or it's like an algorithm that you need to understand. It's just a tool that is over there to help you out, to reduce the complexity of your programs or to just make your life easier, right? And then we'll talk about that is advanced mathematics required. Now, one of the functions that I kind of find really fascinating is the Mobius function. So is this kind of thing required, right? And then why we aren't able to solve the problems efficiently. Then we'll talk of patterns and resources. But there's a catch. Now, these topics, that is GCD, combinatorics, primality testing, these have already been covered in this particular video. So I hope that you have already seen this video. Have you guys seen this video?
Yes.
So
Yes.
did you find this helpful? Did that cover your doubts? Abhi, you were saying this, right?
Yes, sir.
Yeah. Okay, so
Yes, sir, the basic concepts are covered.
okay, cool. So I'm assuming that everyone over here has seen the video. If someone hasn't, could you please tell me? If someone hasn't seen that video and directly jumped over here. Okay, cool. So I'm assuming everyone has seen that video. So let me get started. So we'll directly jump onto the questions then. If everyone has seen the video, so let me jump onto the first question. That is a problem B. Let's look at the problem. Okay. Okay, so the problem states that given positive integer n, find distinct positive integers a, b, c such that a plus b plus c is equal to n, right? Now, this kind of a problem doesn't require a lot of mathematics and stuff, but if you're able to solve this, then you'll realize that how to come up with solutions for intuitive problems and how to get solutions from test cases itself. So what the problem is saying is that you have to give 3 integers and 3 of them should be distinct and positive. So you cannot have 0 as one of the integers, right? And this GCD of a comma b should be equal to n, right? Now how would we solve this? Now let's try with the base case itself. Let's go to the iPad. Yeah. Okay, so this is the thing that is given to us. Now what I'm saying is, let's consider our c to be 1, right? If our c is 1, that means the GCD should be 1, right? Now when would GCD of a comma b equal to 1? Is there any case in which this would happen? So this can happen. So let's say a is 2, right? And b is any odd number. So let's say b is any odd number. Then we'll take the GCD of 2 comma odd number. It's gonna give us 1, right? And we have already said that our c is 1. So this would get satisfied. So in other terms, the a plus b plus c would be like 2 plus some odd number plus 1 is giving is equal to n, right? Now 2 plus 1 is 3. 3 plus some odd number is equal to n, or odd number is equal to n minus 3. Now since n minus 3 is becoming an odd number, hence n has to be an even number, right? Only an even number when subtracted by 3 would give us an odd number. I hope that's basic concept and everyone is clear with that. So that's my first case scenario, or the first scenario is that if I'm having an even number, then my answer simply is 2 comma the number minus 3 or n minus 3 comma 1. Okay, so it was n minus 3 comma 1. Up till this point everything is clear, right?
Yes, sir.
Okay, cool. So with this, what I can say is that the second case is for odd numbers, right? So since n can be even and odd, so what about odd numbers? So is there a possibility that I can have the GCD as 1 for a and b even in case of odd numbers? Let's look at that. So let's say the c we are having is 1, right? So now we will be left with n minus 1. Now n minus 1 should be n minus 1 should be the sum of a and b. Now let's try to break it, right? So when we since we are talking of odd numbers, so when we subtract 1 from it, so n minus 1 is definitely an even number. That means it's possible for us to break it into 2 numbers, right? So we can break it into n minus 1 by 2 and n minus 1 by 2. Now what would happen is that if these two numbers are actually even, in that case their GCD would be equal to 2, or their GCD won't be 0. It can be 2, it could be something more, but it won't be 0, right? So that's the problem I'm having now. How would I change them that their GCD becomes 1? So I can say that if these two numbers are 1 and I decrease one of the element by 1 and increase one of the element by 1, that means that if I say that my A was this, right? So instead of this I just decrement 1 in this, and in my B I increment 1, then the GCD would now become 1. Is this point clear?
Yes, sir.
Okay, so that is something I can do. So now what I said is that if my number is even, then I'm good to go, right? If my number is odd, but n minus 1 by 2 is actually even, then also I'm good to go. The only case remaining is if the number is odd and n minus 1 by 2 is actually odd, then what do I do? So if my n minus 1 by 2 is odd, right? So in that case, okay, so n minus 1 by 2 becomes odd, then it's possible that the two numbers I'm getting are actually divisible by 3, right? So what can I do? So if I increment 2 over here and I decrement 2 over here, right? So technically both of these numbers would still remain, you can say, would still remain odd. So there's the possibility of them having a, okay, so there's no possibility as that these two numbers would be actually divisible by 2 because they are still odd, and now they also won't be having a GCD. Let's just look at the implementation, and then it might even look a bit more easier to you. Okay, so see over here what I'm doing is, firstly I'll check if the number is even. In that case n minus 3 followed by 2 or followed by 1 is the answer. That's the base case, right? Else just check the mid. So if the mid is also even, then in that case I can say, since I'm having two even elements, if I subtract one and add one to the other, in that case the GCD would become 1, right? So I'll be doing that. Else mid minus 2 and mid plus 2 is going to be the answer. So I hope this fundamentals are clear. And the only reason to explain this particular problem, now this wasn't actually a tough problem, but you can see even in the contest I was actually getting wrong answer, right, at many times. So an easy way to solve such problems is that try to go through the easy test cases, or the or you should go through the obvious answers. By obvious answers what I mean is that the extreme answer for C could be 1, right? C cannot be 0, so the minimal answer for C is 1. So what can we always construct the answer with C being 1? If we can, then we already have the answers, right? Had it been the case that it wasn't possible to construct the answer with C with 1, I would have gone for some other extremity. Maybe like I would have gone for C is equal to n minus 3 or something like that, right? In order to check the solution. So extremities are most of the times helpful in problem A, B, C, I can say, or in problem A and B particularly. Because when you're checking for the extremities, most of the times you'll find the answer over there. Okay, so any doubt at this point? Okay, cool. I'm gonna move ahead now.
No.
Okay, cool. Let's check the second question. Let me just. Okay, so this is the second question. Okay, should we do a Codechef question or a Codeforces question? We have two Codechef Codeforces and one Codechef question left. Any suggestions? Guys, Codechef Codeforces.
Anyone could, no problem.
Okay. This is the F question. Let's keep it for the last, right? Let's do this problem. That is the Codechef problem. And the problem's name is possible GCD. So the problem states that you have two integers A and B. Now you have to find that how many distinct values are possible for the expression GCD A plus X and B plus X, where X can take any non-negative integer value, right? So then you will be only given two numbers, that is A and B, and you have to output what's the maximum value. This is actually a good question, requires basic understanding of GCD. It's not like something based on complex theories or something, but it just requires the basic understanding of GCD, right? So you have two numbers, one is A, the other number is B. Now I'm just assuming that A is less than B. If A is greater than B, then you can simply swap it and this would hold, right? So it has some difference. Let's call it diff. Right. Now what we're supposed to give is that we can add any value x to a as well as to b, right? So it would give us a GCD. Let's say this is a. Then we can like say that let's call this GCD as g. Now let's say we changed x. So now it becomes a plus x dash comma b plus x dash. Then we again calculated GCD. It gives us value g dash, right? So we have to give that how many distinct values of g dash so on are available to us. Just to give you an example, let's say the numbers you were having were 8 and 4, right? Or 4 and 8, since a is less than b, I'm assuming. Then in that case you could have said that okay, GCD of 4 and 8 is itself 4. If I add 2 on them, so it would become 6 and 10. Their GCD is actually 2. If I add 1 to them, so they become 5 and 9. Their GCD is 1. What else can I add? Now is there any possibility that I can make some different GCD out of this? No, these are the only possibility. You can try to add any amount x to the variables a and b, and still they'll be only giving you these GCDs, right? That is 1, 2 and 4. So the number of GCDs possible is actually 3, so we'll print the answer as 3. I think 4 and 8 is one of the options they are given. Okay, so they are given 8 and 12. Even in case of 8 and 12, this would actually mean 3 only. Cool. So how do we reach till here? So we say that okay, a is over here, b is over here, as I said, and they have a difference between them, right? Now what I'm saying is that if I move a by amount x, right, so it becomes a plus x, but then I also move b by the same amount, so it becomes b plus x, right? And now even in that case the difference actually remains same. So other thing is that if my a, which, or let's say a dash is a plus x, where a plus x dash, where x dash could be any positive value, right? So there would be some divisors of a or divisors of a dash, right? And there would be some divisors of b dash. Now a divisor of a dash would also be a divisor of b dash. So let's call divisors of a dash as da1, da2, da3, so on. Now a divisor of a dash would also be a divisor of b dash only if the difference also is same, or the difference also is a divisor of the same. Now what do I mean by that? Let's say your a dash value is 10, right, and your b dash value is maybe like 14. In this case the difference is actually 4, right? Now when you check for it, you say that okay, the divisors of a are 1, 2, 5 and 10. The divisors of 4 are, so what are the divisors of 4? So the divisors of 4 are 1, 2 and 4, right? Now what would be a divisor that is present in both a and b? What would be the divisor that would be present in both a and b? So that divisor should actually appear over here itself, right? So the common divisor in a dash and diff is actually 2, right? So in other terms, 2 is the divisor that would be b in cell. I can give you a formal proof for this. So I can easily say that b actually is a dash plus diff, right? Now what I want to do is that I want to calculate some d which actually divides b, right? So that should also divide a dash plus diff. Okay, modulus d should be equal to 0. It can also be written as a dash modulus d is equal to 0 and diff modulus d equal to 0. Or in other terms, it means that variable d should be divisible by both, right? So now I can say that I only want to check what are the possible divisors of the difference, right? So whatever will be the possible divisors of difference, that would actually be my answer. So it's not even related to a and b. I just have to check that okay, if the difference between them is diff, then I just have to check what are the divisors of it. So if it has divisors d1, d2, d3 or d0, d1, d2, then okay, the answer is also 3, because I'll always be able to make the value of a such that one of its divisors become d0. I'll always be able to make the value of a such that one of its divisors is d1 or d2 respectively, right? And when I'll make these, so let's say a dash, a double dash, a triple dash, when I make this, so these values are actually changing, right? But this value is constant because the difference remains constant. So as soon as one of the divisors becomes d0, the GCD of AB would actually become d0 itself. from here and here, right? This is diff and this is a dash. When we are going for D1, the GCD would become D1. When we are going for D2, the GCD would become D2. So it's all about checking the divisors for diff itself. So if I show you the solution is fairly simple. So over here, I'm taking the difference as the absolute, right? Then I'll say that I just want to calculate how many divisors it has. So it's the boilerplate code. What it does is it goes from 1 to the root of the difference or the numbers for which I'm going to calculate the divisors. It checks if the number actually divides or divides the difference. Then increment your answer. Now I say that okay, for a number n, one of the divisors is b, is let's say a, right? Then it actually means that a into b is equal to n, right? Now should I increment my result directly because b would also be there? No, but because what could have happened is, let's say your n was 16, right? Okay, 16, and the a you calculated was actually 4. So in this case your b is also 4. So you should just check that the both numbers are not equal, and if they're not equal then you increment your result, and after that you just print your result. So that's it for this, and I hope that you are able to understand it. Now it is a 2097 question, but I assume that most of the people just saw the trend that okay, the difference is divisible, like it has to be the divisors of the difference, but didn't know a formal proof of it. Just wanted to provide you with the formal proof. Guys, any problems in understanding this?
The last part, sir. Last part did not
Okay, no worries.
understand.
Sure. So basically the last part where I said, give me a second. Yep. Where I said that okay, if a is divisible by something, right, and then also the difference is divisible by the same number, right? B also would be divisible by the same number. That's what you mean? Abhi, is
Yes.
that okay? So see, if a is divisible by x, right? So I can write it like this: a modulus x is equal to 0. Right now, I'm also saying that my difference is divisible by x. Right, so I can also write def modulus x is equal to 0. These two things are clear, right? Now, if I combine these two things, I can write a modulus x plus def modulus x is equal to 0. I hope this is also fine. And I can combine these two things to write a plus def modulus x equal to 0. Now, since a plus def is actually b, because we knew that b minus a is equal to def, right? So a is a plus def is equal to b. If I write this thing over here, so that becomes b modulus x is equal to 0. Okay, equal to 0. So that technically means that if both my difference and my value a are divisible by a number x, then the value b also would be divisible by the same number. That makes sense now?
Yes, yes.
Cool, then can we move forward?
Okay.
Okay, cool. So let's get to the next question. Let's do this problem and then we'll do the Codeforces problem F. Okay. So it is done. Okay, I've already solved it today. Yeah. Okay. So in it says that there are n type of banknotes available, right? And if you have the denomination 10 to power a of I, right? So what's happening over here is that like in India you have no currency notes of like 10 rupee, then a 20 rupee, then 50, 100, 500, like 1000 to nahi, but yeah, you get the drill, right? So in this country the notes are actually of some power of 10. Now like I ask you that okay, give me maybe like 15 rupees in form of notes, right? So you can accumulate a single note of 10 followed by a single note of 5, right? But would it be possible for you to give me 11 rupees? For that you'll have to have a single note of 10 and a single note of 1, or you can have 11 notes of 1 itself. So that's something you can do. So what they're asking is that there would be a number x definitely. So if I say that okay, so the maximum number of currency notes that you can use is k, then there would be a number that you won't be able to give me, right? So the number could be like let's say you're not able to give me 749 rupees or something like that. So you just have to print 749 because since k is limited, so definitely the answer would exist, but we have to give them the smallest possible value of money or rupees or whatever currency you're talking about, and which you won't be able to give me. Is the question clear, guys? Is the question clear?
Yes, yes.
Okay, so how can we do this? Any hints about it? Because it's a simple problem, also from an education round. So I'm not assuming that everyone would know how to do it, but still, if anyone has an idea, so you can share that. Cool. No, let me start with the solution itself. For this, we'll be talking about how numbers are actually represented. So we have always worked with numbers, right? So we know that how to write numbers and stuff in the decimal format. So we know that how to write 123 is 123 or 1467 or any other number is just in this form. Or we can say over here, as we learned in the school days, that this is at the 0th location, this is at one's location. Oh, sorry, this is at the 0th location, so this is at the ones places, this is the tens places, at the hundreds and at the thousands place, right? Now, in other terms, I can say that if I have a you can say a currency note whose value is 1, then I can use 7 currency notes, right? For this, I can use 6 currency notes for the value 10. I can use 4 currency notes of value 4 of value 100, and I can use 1 currency note of value 1000, right? So if I do that, then in total I'll be using 1 plus 4 plus 6 plus 7 currency notes to represent this, right? Now, if would it make sense for you to utilize more number of currency notes for what do I mean by that? For example, if you want to represent 11, right? So you will be using 1 currency note for 10 and 1 currency note for 1 itself, right? But would it make sense for you? So in this way, you will be using 1 and 1, that is 2 currency notes in total, right? But would it make sense to you for you to actually use 11 currency notes of 1? No, it definitely won't make sense, right? Because you want to minimize the number of notes you're using. So with that, what I can say is that I'll start from the lowest currency note, right? So the currency notes that would be provided to me would actually be given in a increasing order. So they would be giving me with the value a1, a2, a3 up so on to an, where a naught is actually 1, and what these values are is actually the value of the denomination in the form of 10 to power ai. So ai equal to 0 means that it's basically 10 to power 0, that is 1. So it's a 1 rupee currency note or a $1 currency note, whatever you want to assume. And if let's say ai is equal to 3, then it's a $1000 currency note, right? So you will be starting from the value 1 itself. Then you'll check that how many okay, so if you have other note or the next denomination that you have, so let's say the current denomination is 1, where ai is equal to 0. So you said okay, 10 to power 0 is 1. So said okay, its value is 1, and the next value is maybe 10, right? So at max it makes sense for you to only use 9 notes from this, right? Because using more than 9 notes is actually stupidity. So in any case, if you want to represent any number, it would always make sense if the amount required by using this zeroth, this particular denomination, if it's greater than 9, then you can always use the next number, right? But this thing can actually change. Now what if the next number was actually 100, or over here ai is equal to 2, so 10 to power 2 becomes 100. Now if this kind of a value was given to you, then it would have actually made then over here you would actually require to use 99 you can say 99 notes or 99 currency notes, right, to represent the values from 1 to 99 itself. So maximum number of notes you ever have required to before reaching this at this place is actually 99 currency notes. Now how do we take that? So the check is actually very simple. What I can say is that okay, so you are giving me a value 100 over here. The current value I have is 1, so I can do 100 divided by 1, or I can say that ai is equal to 2, and over here ai is equal to 0, so I can say 10 to power 2 minus 1, or 10 to power 2 minus 0, that is 100. So from this till this position I need 100 minus 1 notes, right? that's the simple logic I can use. Now for every positions from like I told you about A0 and A1. So for every position A1, you'll check that how many nodes do you need, or how many currency nodes do you need to reach to the next position, right? If you have sufficient number of currency nodes, then you can move ahead. If you don't, then you have to print the maximum value plus of what you make. So the solution over here is, okay, yeah. So yeah, one thing over here. So whenever you are solving questions related to mathematics, a lot of time what happens is that I have actually seen this happening quite a lot in the past few contests. So sometimes they'll be giving you with values because of which your standard implementations of C++ or whatever language you're using would actually fail. For example, this happened in a recent contest on Codechef, if I'm not getting it wrong. So over there, people had used the cube root function, but the internal cube root function would actually fail for such values. So you were expected to implement your own cube root function. So over here also, if you use the predefined power function, then it might fail. So it was actually failing for me. That's why I was getting a wrong test case. So over here also you have to make your own power function. So binary exponentiation is one thing that you can utilize. That's actually an easy thing. So I'm not going in the details of it. In the previous video, I already mentioned how to use binary exponentiation. It simply gets you the power n comma x over here, or x comma y basically means that it is going to return us x to the power y. So that's the utility of this power function. So what I'm doing is that starting at the current index, I'm going to check the index just after me, right? So I'm going to say that, okay, the current index is I plus 1, the next the current index is I, the next index is I plus 1. So the amount of nodes that I would need, right, would be given by power of 10 to the power, whatever the next current is, minus the current denomination, right? And minus 1, because it will give you the whole value. So it will say that, okay, if you are having a 1 currency node and you want a 100 value, then you'll actually need 100 currency nodes. But I only need up till 99 because 100 I anyway can make by the next node itself, right? I'll be subtracting 1 from this. Then I'll see that if the currency nodes I'm allowed to use, if they are actually less than what this use value is requiring me to use, in that case I cannot proceed further, right? And I'll have to print the value. So what I'm gonna print, that will cover later. But then but if this doesn't happen, in that case I can utilize these nodes to make that particular value. So I'll just increment my past. I'll increment my past by a use. So these are the number of nodes I'm using, and this is the value of that particular currency node. So that is simple standard stuff. And I'll have to decrement my k by the number of currency nodes I've already used. So I'm doing this here. Now in case my like the currency nodes I was having were not sufficient enough, in that case the value I was printing was past plus power of what like this is past, this is the value of the current currency node, right? But over here I'm actually multiplying it by k plus 1 because you can already utilize currency nodes. So the value you won't be able to make is actually k plus 1 itself, right? Because up till k you can make the values. So k plus 1 is the first value that you won't be able to make. Else, if you're able to terminate this entire loop, that means you were able to, make numbers up till the last denomination. So in that case, there would be some like finite number that would be greater than the value at the last denomination that you won't be able to make. So if that's the case, then just print actually it's the values of past plus k plus 1 into power or whatever last value is. I hope this made sense, guys. Because now I'm gonna discuss the F problem. So if there's any doubt, let me know.
Sir, can you try another example? Any one example?
Sure. Okay, so let's start with 0, maybe, if that makes sense. So let's start with 0 and 2, and it's 313, I guess. Yeah. Okay. So the values over having is 0, 1, 2, and 3 is actually not significant because I already wrote that. And the currency notes you can use, or k here was 13, right? So this actually means 10 to power 0. This means 10 to power 1. This means 10 to power 2. So this is a 1. So this is a 1 rupee currency note, a $1 currency note. This is $10 currency note. This is $1 currency note, right? Now I ask you that can you make the value 10 or the value 9. So can you make the value 9 using notes from this? Do that. So you'll say that, okay, how many currency notes can I use? So you'll say that you can use 30 currency notes. So you'll say that, yeah, so if I use 9 currency notes, I'll be able to make this particular value, or the value in front of me -1. Say I'm good enough. I'm cool enough with that. So how many currency notes do you require over here? I exactly require 9 currency notes. So you'll subtract 9 from here, right? So your K would now become 4. Yeah, so you'll subtract 9 from 13, your K would now become 4. Now you'll get to 10. Now at 10, you'll see that are you able to 100 using the currency notes you have. So he'll check that, okay, for 100, I need 10 currency notes, or to reach up till 99, I would actually need 9 currency notes, because 9 is already available, right? And if using 9 currency notes, I can make a value 90. So if I have 9 currency notes, then I can proceed further. Make sense? Then in case, then he'll tell you that, okay, you don't have 9 currency notes. So you ask him that, okay, how many currency notes do I have? He'll say that you have 40 currency notes. So he'll say that, okay, give me 40 currency notes. With 40 currency notes and using using the last notes I had, I would be able to make 49. So 49 is something you can make. Can you make 50? Now you might say that, okay, 50 is also 50 won't also be possible, because at max you're able to make 49. That's actually not the case, because what you can do is that you can say that, okay, I'm gonna use all the notes, or I'm gonna use 5 notes of the denomination 10, right? If I do that, then I'll be able to make 50 as well. So that's not the answer, but rather what you'll say is that, okay, 49 is doable, but 59 won't be doable for me, because at max I can use like this is the max value I can make, right? Now if 9 is fixed, if this number is already fixed and I can only vary this number, so for this number the K has already been varied. So since I can only vary K, or I can only vary 4, and since it's max, then the next value would be the answer. So I cannot make 59, or I cannot make 49 plus 1 over here. So if there was any values over here, you'll just put x is over there. So the answer is 59. So we'll get to that point and you'll return the answer. Does this make sense now?
Yes, sir. Yes.
Cool. So with that, we are done with all these problems. Let's move to the, I'll say this is one of the easiest problem you can see, but it was still given in the div 3F. So if you're able to do this kind of a problem, you will end up, being an expert pretty soon. And the way I'm going to explain this would actually require just maybe 4-5 lines of code. It's not even related to DP or binary search, nothing related to that. So I'll make it pretty easy for you. So the question actually is that you are given two integers L and R, where L is less than R. You will add 1 to L until the result is equal to R. So definitely it will be exactly R minus additions. So if you are given with a number L and the R is 3, and I ask you that keep on adding 1 to L till the time you reach to the value 3, then it's obvious then you'll have to add it to add 1 2 times on L to make it right. So for each addition, what we actually have to do is that we need to look at the number of digits that will be changed after it. So for example, if your L is 909 and you add 1 on to it, then it becomes 910, right? So in 910, the 0th index and the first index actually change, right? Looking from the right, so the 0th and the first index, right? And if your L is 9, then also 2 digits would be changed. Now let's say this was the number you were having. When you add 1 to it, all of these digits would change, or you can say that 5 digits changed. Now we have to tell that what is L minus R. So how would we do that? Let me explain you the intuition, or very easy. So whenever you add a 1 to it, when any number, so you add a 1 to 0, it becomes a 1, then you add a 1 again, it becomes a 2, so on and so forth, right? So on addition of 1, all numbers change by, or all numbers at least change by 1 digit, right? But what would happen that after you have added 1 10 times, right? On the 10th time, your 9 would become 10. So this is actually a increase of digit by 2 or increase by 2 digits. On addition of 100, it would change by 3. On addition of 10 to power 3, it would change by 4, so on and so forth. But since 1 is already calculated, so let's just write it as 1, because I say that, okay, when you go from 9 to 10, so 1 of the contribution is coming by the second digit, and one of the contribution is coming by the 0th digit, right? So since I'm already considering the 0th digit, let's just say the contribution of 10 itself is 1. Then I'll say the contribution of 100 is also 1. So it becomes that contribution of each of the digit is actually 1 itself, right? What do I mean by that? So that what I mean is that if I'm going up till 1000, so if I'm going up till 1000, then uh, 0th digit, right? 0th digit would be updated 1000 times. So I'll say okay, 1000 0th digit would be updated. What about the digit at this particular location? So this digit would actually updated 1000 divided by 10 times, that is 100 times. So plus 100. The next digit would actually be updated only 10 times, and the last digit will only be updated by one time, right? So this would be the sum of this would actually be the sum of the digits that have been changed. So can we just print r minus l, and like we'll get a value. So for this value we can easily check that what the answer would be. Let's try this out. So I'm going to code this question right away. So let's try this out. So if you are able to see this, then, or if you are able to assume like check how I'm doing this, maybe you'll start understanding that how I actually code and how these things are actually intuitive. Let's take two numbers as specified. There would be L and R. At any moment, if you are not able to hear about, please let me know. Okay, so I'll be using two variables L and R. After taking them, I'll check the def. So my def would be R minus L, right? Let's see out def. Okay, and calculate. Okay, let's change digs change. Let's call it. Let's have its value x, right? Now I'll say that for int I equal to 1 till the time I is less than equal to what value, or okay, less than equal to x I plus plus, not I plus plus, but I want to multiply it by 10 every time. Okay, interest equal to 0, rest over here. Then I'll say that okay, so I'll increment my rest by what value I want to increment my rest would be x divided by guys, at any time if you're not able to understand the logic, please let me know. So rest plus equal to x divided by 1 would be that. Let's try to print it directly. So I'll be printing the exchange of def. Let's try this code. Okay, let's see the output. Okay, so I already entered the input. So over here the input is this, right? And this is the answer I'm getting, which definitely is not correct. It's correct for the first thing, that is 1 and 9, right? But it's not correct for anything after that. So for 9 and 10, it's giving me the value 1, right? It had to be the value 2, right? So on and so forth. So why is this the case, or why is this happening? So the simple thing is that we assumed that this would happen, but let's say the value of L was actually 999 and the value of R was actually, okay, it was just 999 and this was 1000, right? In that case you would say that the difference of them was actually 1, right? But in reality the difference is actually the difference is already all the 1, but since it's occurring after 999, so because of that because of that the digits that's gonna change would be much higher, right? So how do we detect that kind of a thing? So since there's no continuity in the equation, it's breaking. So for that what I can say is that I don't want to calculate it for the digits, right? I'll just calculate it for R and simply subtract it for L. That would give me the answer for the range L to R, right? That makes sense, I guess. Let's try that. Okay, I think that the answer looks fine to me. Let's remove this. If you want to make it shorter, not required though, you can actually do it like this. Looks more clean, I guess. Try again. Okay, let's just try this solution. Okay, submit, paste. Okay, see, you can see this is the AC. Okay, what AC was it? Okay, it got accepted. So even the F problem of div 3 was so easy if you are good with the basic mathematics, right? So had you gone through the solution of a DP problem or making it a binary search problem, then eventually you would have been able to solve it, but solving it would have been somewhat tough, right? So understanding how easily you can solve a problem actually makes a lot of difference in CP, where time is actually a crucial factor. So these were the problems I wanted to discuss today. So with that, the problems are done. We discussed all of these 4 problems. One of them, which was actually a good problem, I'll say. I hope you were able to understand them. So there are a few pointers that I want to discuss. So like primarily, I hope that the like these topics are already done by you or you watched that video. So are there any doubts you want to discuss, guys? Is there anything you wanted to know?
So how to think like that, sir? Just like sir, in start, sir, we are unable to think, sir, how to approach maths problem. This is a maths or this another topic.
Bro, so see, when you look at a problem, right? So the first thing is that look at the constraints. So okay, if I go to this particular problem, I look at the constraints. So the constraints are that L is less than R is less than 10 to power 9. Now the extremities over here would be that L is equal to 0 and R is equal to 10 to power 9. Now, any other solution, if I'm iteratively, going about it, then it is going to give me a TLE. The only two possible solutions over here is, or three possible major solutions would be either having a root n approach or having a log n approach. Right? Even root n would fail. Now, why would root n fail? Because this would become technically in a root scenario, it would become 10 to power 3. It actually might pass, but yeah, it's a bit tricky. So anyway, so talking of that, so if you are coming up with a log n approach, then at this particular level at which you are, most of the times the answer is going to be binary search, right? So you could have tried it with binary search, and even with binary search, you would have gotten the right answer. So since binary search is one of the probable solutions for this, you gotten the right answer. The other scenario is that you need to think that when this particular thing happens, so when this particular thing happens, by that I mean that when would a digit particularly change? Now I already explained that in on every addition, your character at the 0th location is going to change definitely. So that is something you know. Now what about the character at the first location? That would change after 10 occurrences, right? The character at the third location, the second location is going to change after 100 occurrences, then 1000, then 10,000. So that's the drill. Now when you write it down, so the problem would actually become much simpler for you. You'll be able to analyze that, okay, so this digit is going to change after 100 times. So if I want to calculate that particular number, how many times would it contribute to the answer? So how many times would this operation happen? So that would be easy for you. So for any index at I, you will just divide the value by 10 to power I, and you'll get answer, right, for that particular digit. Now after that, like over here when I reached to the solution, then I told you that okay, so the answer is not coming right because there are scenarios. For example, you have the number 999 and that then that is becoming 1000, right? So that kind of scenario, you'll detect the answer to be 1 or the difference to be 1, but the answer is going to be much more than that, right? So because in that kind of a scenario, you need to understand that something else is required. Now there could be two ways of fixing it. One way is that you actually change your approach a lot and stuff, but other thing is that you could have realized that you could simply subtract the value so you could have subtracted the answer for 1000. So let's say this was f1000 and this was f100. So f1000 would have given you the number of digits change for the value 1000, and f99 999 would give you the number of digits change for 999, right? So the only remaining scenario over here would have been the transition from 999 to 1000 itself. So that way you could have got the answer. Or in the first question I discussed, so in this question, the entire thing was that checking for extremities, right? So if you are able to check for extremities, then you'll be able to detect. I hope that makes the point clear.
Yes, sir.
So yeah, the thing is that you'll understand more about it after solving some more questions and with practice. But the entire point was to give you with some tips and tricks. So at least now when we look at a question and the input is such that you'll definitely know that you don't need to you cannot go with the iterative solution for this and stuff. So once you start figuring that out, then your mind automatically would look at mathematical solutions. And if you have the basics clear, now GCD and devices are such thing that you cannot do CP without them, right? So you have to understand what devices are and what GCD is, what LCM is. These are actually the basic stuff. So if you're able to understand that, okay, this needs a mathematical approach, what could be the basis of this, then automatically you'll eventually come to an answer. Obviously, it might take some time and practice for that, but you'll definitely do. Cool. Any other doubt?
So placements are coming, sir. Any tips for that?
Bro, for placements, I'll say that these mathematics questions don't usually come in placements. They might actually, right? But they are not of CF level most of the times. So for placements, I'll say keep a bit, go a bit hard on LC. That should help more than doing CF. But yeah, doing CF actually makes you think in the right direction and stuff. So that's also helpful. But LC is something you cannot ignore for placement per se. So don't stop doing that. Because let's say even if you are maybe expert on CF, but that probably would mean that you still don't utilize graphs often, right? And placements, it's common to have questions on graphs. So that is something that could mess you up. So I'll say do both, but if placements is pretty near, then stick to LC for a while.
Okay, sir. Thank you.
Cool, bro. Anything else? Okay, so if you have something, you can interrupt and just ask it out. So the other thing is that I want to discuss that is advanced mathematics required. So there's something. This is a very popular function known as Mobius function, right? Now, if you are already at a level that is beginner level, or let's say you are somewhere in newbie or pupil range, or even a specialist at the moment, so there's no point of studying Mobius function. I don't expect that Codeforces would give you a question related to Mobius function in A, B, or C, right? So it would be overkill as of now. So in this particular level range, if you are even up to expert, or like if you want to transition from expert to candidate master or master, then definitely these things are required. But in this particular range, just doing the basic stuff and having a good idea about GCD devices and primality testing, combinatorics, these things actually help. So I said it's not required right now. So you can do it, but put it at a later on stage when you actually reach that level. So why we aren't able to solve maths problem efficiently? I already answered this for Abhi. So he already asked me the same question that why we are not able to tackle it, and I gave you a few tips and tricks, so that is covered. Now talking of patterns, so one easy thing to do is that you can look out for patterns. I'm not sure if there was a observable pattern over here. Yeah, so just giving you a tip. So sometimes if you're not able to understand what the pattern is, you can start brute forcing it up. So say constraints are actually going up to 10 to power 9 or something, so brute force is going to give you a TLE, but you can make a program and test it at random inputs of less volume. So let's say even if your input is going up for 10 to the power 9, you can test it maybe up to 100 or up to 1000, right? And just try to see that what kind of answer your system is generating in a brute force manner. In that kind of a scenario, it's possible that you see some pattern and you're able to detect the answer. For example, in the first case, is the first problem we discussed, that was yeah, this problem. In this case, the answer would always exist for C is equal to 1, right? But in the output, they had actually given answers where C was equal to 1 in only one of the test cases, right? But let's say you made an algorithm which did the work in a brute force manner. So that over here would be a n cube algorithm, but anyway, it's gonna work for inputs up to 100, right? So you could have utilized that particular algorithm. It won't be an n cube, but yeah, n square algorithm actually. So you could have utilized that algorithm to check what are the possible answers, and then you would have probably realized that okay, answer always exists for C is equal to 1. Now this is kind of a hacky way. You can use it to increase your rating. It won't be like beneficial in the longer run, but yeah, this is one of the way you can start building your own intuition. It's far better than actually seeing someone else's solution and trying to understand. This way is actually better. But make sure once you are able to solve a problem in this way, after the contest, at least try to understand the reasoning behind it, that why it was happening. Okay, moving ahead to resources. So yeah, there are some good CF resources. I'll put a link to them on the Discord server and also in the description of this video, so you can check them out. Although don't give it a overkill, like don't study it too much, so much that you actually have to compromise on other aspects. So these resources should only be used when you think that all you're already pretty familiar with the basic concepts of like I already explained of devices, GCD and stuff. Once you're familiar with those, then you can go for these resources. Before that, I don't like I won't advise you to go for them. So cool. With this, I'm actually done. If anyone has a doubt, he or she can ask that up. Else, I'm gonna close the session. Okay, guys. Cool then. Bye bye.